Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 19th March 2023. The problem statement for today is distinct difference. This problem is based on set and arrays. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The given problem statement is given an array A of length n for each index I, that is 1 less than equal to I and I less than equal to n, find the difference between the number of distinct elements in its left and its right side in the array. So for in this array A, which is of size n, we have to find the difference for each element between the distinct element in its left and its right for a given index I. Okay, so this is the simple problem statement given. So let's understand it better with this example. So in example 1, it is given n is equal to 3 and this is the given array. So here the output is -1, 0 and 2. So explanation it is given are, therefore index 1, there are 0 distinct element in the left side of it and 1 distinct element 3 on the right in its right side. So the difference is 0 minus 1 is equal to -1. So here that means starting when I is pointing to 4, that time we are seeing that there are no element to the left of 4. So that's why there are 0 distinct element on the left of it. Okay, and when we see to the right of 4, we see 2 elements are there but both are same, that is 3. So only 1 distinct element is there on the right side. So the difference is 0 minus 1 is equal to -1. When we advance to index 2, so and that means I is pointing to 3, so that time we can see there is 1 distinct element, that is 4 on the left side, which is this one, and 1 distinct element on the right side, which is 3. So the difference is 1 minus 1, that is 0. So the second output is here is 0 in this array. And when we iterate further, then when I will be pointing to 3, so there we can see on the left side of it there are 2 different elements, which is 4 and 3. So there are 2 distinct elements 4 and 3 on the left side of it, and on the right side of it there is 0 distinct element, because to the right of 3, the last index, we do not have any element there. So the difference is 2 minus 0 is equal to 2. I hope this is clear. Let's go through the second example. Here it is said that given array size is 4 and this is the given array where it is containing the elements like 4, 4 and 3, 3. So the output is -2, 0, 0 and 2. So here we'll go through this explanation once here. So for index 1, there are 0 distinct element on its left and 2 distinct element 4 and 3 on this right. So again when I is pointing to this 4, so to the left of it, since there are no elements, so 0 distinct element on the left, and to the right of it there are 2 distinct element, which is 4 and 3. 3 is repeating, yeah, but so we have to consider only 1 3. So here the difference between this left and right is 0 minus 2 is equal to -2. For index I is equal to 2, there is 1 distinct element on the left side, that is 4, and 1 distinct element on the right side, which is 3. So since there is only 1 distinct element on both sides of it, so the difference is 1 minus 1 is equal to 0. So same will happen for even for this one 3. 1 distinct element on the left side and 1 distinct element on the right side. So again the difference will be 0. Okay, and so when we go to I is equal to 4, so to the left of it we can see there are 2 distinct elements, and to the right of it, since there is no element present, so the distinct element count is 0. So that's why we do left minus right is equal to 2 minus 0 is equal to 2. I hope the given examples are clear. So the approach we can use is to use 2 HashSet to calculate the difference in the number of distinct elements on the left side and right side of each other. Then in the first step, we will try to iterate from the end of the array and calculate the number of distinct elements on the right of each index. This we will do using a HashSet to keep track of the distinct elements and counters so far. The number of distinct elements on the right side of index I is stored in the array called distinct size that we will define. In the next step, we will iterate from the starting of the array. Previous step we started with the end of the array, but next time we will start with the starting of the array and calculate the difference in the number of distinct elements on its left and right of each other. This is done again using another hash set to keep track of distinct element encountered so far on the left side. The difference in the number of distinct element on the left side and the right side of index I is calculated as left set dot size of minus distinct size of I, which we have created in the previous step, where left set is the hash set of distinct elements encountered on the left so far. The difference is then added to the array list answer. Finally, the function will return the array list answer containing the differences in the number of distinct element on the left and right side of each other. So I think this approach is very clear. We will be simply using two hash set, one hash set to calculate the number of distinct element on the right side and the second one to the left side, and we will find the difference there, and whatever the difference we get, we'll just keep on adding to the answer array, that is the resultant array. So with that approach we will code this. So just to save time in typing, I have prepared this solution. I'll just copy it here. So this is the same thing whatever we have done here. So I'll just explain it line by line. I have even given comments against each line so that this becomes self-explanatory. So here we initialize an empty array list to store the answer. That means to store the answer or the result. Then we initialize an empty hash set to store the distinct element on the right side of each index. Then initialize an integer array used to store the number of distinct element or the size of distinct element on the right side of each index. That is this one, distinct size. Then calculate the number of distinct element on the right side of each index by iterating from right to left over the input array. So for iterating from right to left, we are starting with n-1 and we are going up to 0. Then for each index I inside this loop, we store the size of the hash set containing the distinct element on the right side of the index in the distinct size array at index I. So first, whatever is the size we have got, distinct element size, that we are storing it in this index I. Then we add the element at index I to the hash set containing the distinct elements on the right side of the index. So here one thing to keep in mind, that before adding the element to this one right set, we are first taking whatever the previous size is there. So this is done because if we are pointing to the rightmost element, if I is pointed to this one, so if we add it initially to the right set, so the right set then the difference where we see that right side was 0, since the I is pointing to 3, then there are no distinct element on the right side, so it should be 0. So that scenario will not be considered. So that's why when it is pointing at this 3, we will see what are the number of distinct element on the right side. Since there are no distinct element, we are taking that size as 0 here, and that we are assigning into this size of at index I. Once this is done, then we add that element to the right set, so that can be useful in computing the distinct element size in the next iteration. I hope this point is clear. Then once this loop is completed, then we initialize an empty hash set to store the distinct element on the left side of each index. Then we calculate the difference in the number of distinct element on the left and the right side of each index by iterating from left to right over the input array. So here we are iterating over the input array and we store the difference between left and right sides of each index. For each index I, we calculate the difference between the size of the hash set containing the distinct element on the left side of the index and size of the hash set containing the distinct element on the right side of the index using the dist size array. Add the element at index I to the hash set containing the distinct element on the left side of this index. Then whatever the difference we have got, that we have to add it to this answer array list. Then once even this is done, then we simply return the array list containing the result, which is this variable answer. I hope the given approach and the given solution is pretty clear. So first we will calculate from the right side, then in the next iteration when we start from the left side, we keep on finding the difference, and the difference we keep on adding to the answer list. I hope this is clear. Again, here also, first we calculate the difference, then we add that element to the left set, again for the same reason. When I is pointing to this 4, so there are no element on the left side. So if we add it before, then we will not get the correct difference value there. Because if you add it here, then even for the first element, which is 4, it will say that set contains one element, which is not correct. So first we will find the difference where the left set will be left set dot size will give 0. So that is correct as per scenario, because to the left of first 4 there are no elements, so the size will be 0. So that's why we first utilize the size of this left set to calculate the difference, then we add it to the left set, the way we did for the right set. I hope this approach and solution is pretty clear. Let me try compiling this code. So here we can see we have got correct output. Let's try submitting the solution. So here we can see it has all the test cases for this given problem is cleared, and it has passed all the test cases, and this problem has been solved successfully. So talking about the time complexity of this solution, it is in the order of big O of n, where n is the length of the input array. This is because we loop through the input array twice, first to calculate the number of distinct elements on the right side of each index, then to calculate the difference in the number of distinct elements on the left and right side of each index. Both loops iterate through the array exactly once, so the time complexity is big O of n in total. The use of set to store distinct element ensures that checking for distinctness takes constant time on average, giving us the overall time complexity of big O of n for the entire program or the algorithm used. So I hope this is clear. So yeah, so I'll provide the link for this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.